first knew about this school, maybe 6-7 months ago, no, slightly longer than that, I was absolutely fascinated because in my mind, it fills a void that exists in architectural education and construction education and management education and all the other ancillary disciplines. And that's why a program like this is of critical importance to face one of the most important of the 15 global challenges that the United Nations has established, and that is sustainability of the built environment. And I think in general you will be equipped with a set of skills that are absolutely phenomenal to deal with those changes. But what I'll probably do is begin by telling you a little bit about the College of Architecture, because then I'll put in perspective some of the rather crazy things that we do over there. We're structured a little bit differently because we're a public institution, we're not a private institution. We have a tripartite mission, which is the learning teaching mission, it's the research, creative work, and scholarship mission, and the engagement includes everything from practice to outreach to even social service oriented architecture, landscape architecture, land and property development, construction management, facility management, and visualization. In the school, we offer a total of 16 degrees that go from in the college, I should say, we offer a total of 16 degrees that go from a bachelor's degree in environmental design all the way up to a PhD. That's what we call home, and we'll come back to this picture a little later, but that's the main architecture building that we have, and this is another building we use that's next to it, and we use the lowest floor of that building, and then squished in between these buildings we have a wood shop. So you see, we don't only talk about things, we actually do them. And this is what we affectionately call the ranch. This is where we're able to build full-size things. So just for kicks, I'll tell you, we built a car out there for the engineering folks because they had CAD drawings of the bodywork, and we CNC milled that into foam, which made the foam panels, and they were able to lay fiberglass and carbon fiber over these molds, and so we do that for buildings. Just over to the side over there, right there you can see a little bit of it, and then again on the other side we have a daylighting lab where we actually test out different types of daylighting solutions in before we. So this is complicated, but here's what we have. Whoops, wrong. Got it. Oh, yes. Okay. So we have four departments: architecture, construction science, landscape architecture and urban planning, and visualization. Each of these four academic departments are responsible for delivering the academic program. Okay? On the other side of it are research units. Okay? And so we have several research, the Center for Housing, Health Systems and Design, the Center for Heritage Conservation, the Center for Housing and Urban Development. My center for CRS stands for Cordell, Rowlett and Scott, and we deal in management and practice in the design and construction industry, and a hazards reduction and mitigation center. So essentially we have those four departments, and then we have these 5 centers. And we have a whole bunch of other little units which are not officially set up as units, but they revolve around interest of faculty. So if you have, 5 faculty who are interested in something, and then it suddenly grows. The Texas target communities is a great example of that. There were a bunch of faculty who went out and helped small little towns in Texas, and then more small little towns came and asked, and it got bigger and bigger, and students got involved in it, and it's a full-fledged center now. And so we like to keep those sorts of options open, and they're at a level below the major centers. Most of these are related to one of our centers. For example, there's the Energy Systems Lab, and I just talked about the Lighting Lab. And we have some strategic partnerships with other universities, with other components of Texas A&M. And so this is sort of the best way that we could show how we organize ourselves. And it's not really as nice and clear in little boxes and bubbles, but then that's part of what it's all about. You need different things to happen. Unplanned encounters are probably the most productive type of academic activity. So let's talk a little bit about BIM over here. Okay. I'm not really quite sure what it is when someone says BIM to me. Are they talking about a building information model? Or are they talking about building information modeling? Or are they talking about building information management? Or are they talking about building information maintenance? It's often a combination of these. Imagine how dangerous it would be if you had a building information model of a space and you made decisions on that model and there were changes made in the real building and they were never ever reflected in the model. That can become a life safety problem. So just maintenance is becoming critically important, and there's some industry studies to show that, and I'll hit on a couple of them as we go through. So maybe when we're talking about BIM, we should talk about BIM plus L plus M plus M, or write it that way, because as you go further along in the process, there's more information and the M becomes bigger. Okay. I'm going to talk primarily about building information modeling because I'm going to show you 3 little pieces of work that we do in my center. This is a definition I found, which is not attributed to a single person, unfortunately. It's a combination of various definitions that works really well. But the key issue to remember is that building information modeling is a collaborative way of working. It's a process. And essential to that process today are digital technologies, and they are all focused and geared towards better designing, creating, and maintaining our physical built environment assets. That's about as comprehensive as it can get. There are various levels and various scales that make it almost impossible to have a single building information model that means everything to everybody. And that's a whole another lecture altogether. But if we remember that it is not just a piece of software, but it is a way of working, I think that helps all of us along the way. I miss these days. All of this was critically important to us. That was all information, and that over there, and that over there. But it was all contained in there. So it was really useless to anybody else. Buildings today are way too complex for that to happen. And so we have to find out why. What are the problems that we encounter? Well, there are lots of barriers to break that. I've divided them up into essentially 3 categories. The first one is people. we can be sitting down and talking to somebody, and if the jargon is not correct and there isn't a reference point of us understanding the other person, it could as well be a big brick wall. That is a problem. Okay? Our processes are incredibly complicated. How many of you have tried transferring data from one computer program to another and it didn't go exactly as you thought it was going to go? That's never happened to you? Happens all the time. Ever tried doing things, transferring data between two different versions of a piece of software? We have processes that we have made unnecessarily complicated. We have to solve those problems. And we have technologies. Okay. There are many things we do today, and we'll take the construction industry as one of those, where we design things with these super fancy machines and software and everything else, and then we actually implement those designs using prehistoric technology. There's a mismatch in technologies, and much of that comes about because of silos, because there are people who are only interested in what they're doing and nothing else, okay, and they're comfortable in their own silo. And what building information modeling tends to be able to do is to let the fringes begin to interact. The place where they're really close to each other, that starts to disappear, and it becomes three bumps like that, but it's essentially one whole. And that's one of the advantages that maybe we do not exploit enough. So obviously we have some bridges to build, and we don't want them to end up like this, okay, because that can be fairly catastrophic. So we were talking about Chuck Eastman a little while ago, and at some point in time, each of us has made numerous of these diagrams, over the past 12, 15 years. But Chuck Eastman, who's at Georgia Tech now, put them together in a really useful way. So I'm just going to talk a little bit about this. Okay, got the wrong one again. These vertical slices represent the different phases of a project, okay? Design and construction, and then use. Now, in the traditional process, by the green here, all the decisions we make, the richness of all the discussions about a project that take place over there, most of that gets lost as soon as it gets handed over to be designed. Why does it get lost? Well, everybody is well-meaning, but you can't remember everything. And there are a whole different set of players and actors. And so everything changes at that level. Okay? So you essentially start out again in design and construction, and then you very rapidly build up a level of information. Okay? Unfortunately, the people who design and construct these things are not the same, the people who design these things are not the same people who construct them. So how do we typically communicate between these two phases of a project, between design and construction, between design and construction? How do we typically communicate information about the project? Drawings and specifications, three-dimensional models. Okay? Are they always perfect?
No.
One of the reasons, and I don't know about India. Okay, my information is not current, But one of the reasons the construction industry in the United States has a 40% waste factor is because everybody is not singing from the same sheet music. Everybody has their own perspective, and critical pieces of information are never passed along because there isn't an understanding, there isn't a sensitivity to how that information may be important to somebody else. That is one of the reasons that we have the amount of waste that we have, and particularly when it comes to details. Cutting down, and this again are American figures essentially, cutting down the number of change orders and requests for information, RFIs, in typical American products cuts construction cost by 20%. So there is the National Institute for Building Sciences in the United States called NIBS, okay, and NIBS are the people who are at the forefront of establishing a national building information modeling standard. Okay, so NBIMS, and we're now at version 4 of NBIMS as it slowly gets more sophisticated. And we decided that we were going to do a study to try to quantify 3 different types of projects, small, medium, large, in 4 different areas of the country based on construction cost in those areas. 1 project done with BIM, 1 project done without BIM. And then we were going to see if we could make some sense out of the data. Now, you know, it was not a large enough sample and all of that neat stuff, and I'm the first person to agree with that. But we did not even have any idea of what it would be or what it could be. So after about a year, we got all this info. Oh, there was another problem. Everybody who gave us information gave it to us voluntarily. Okay, so we were dealing with people who were really interested in knowing the difference. That does not mean that the data will be the same if people are dragged into this, you know, kicking and screaming reluctantly. And we discovered that the contractors who decided to make a building information model after receiving the drawings from the architect, drawings and specifications from the architects, saved on an average 25% of the cost of construction, primarily in requests for information from subcontractors and change orders because that's not what the client wanted or asked for in the first place. Okay? Did it cost them time and money to crank up and put together the infrastructure to make a building information model? Yes. And that was typically around 8% for training and hardware and software, 8% of the project cost if they did it for the first time, and then after that it was gravy. So what happened to the rest of the money? Well, the contractor was able to go out and buy a new portion. You know, it was that simple. They just got that much extra profit out of this, and that is the reason why building information modeling is coming in backwards. The people who are seeing the economic benefit first are the people who are using it, and then they're forcing that. So when it should be progressing this way, it's actually progressing from here that way. Okay? And now it's kind of reached about halfway here, and I'm showing you this because of something I'm going to say in a little bit. And that is that in a typical traditional process, the green one, at the end of design and construction, that's it. That's where the information stops. Very rarely do you actually get, we have started to see more of it. I don't know how prevalent it is in India right now, but very rarely do you get manuals and instructions from the contractor of how to operate the building. But that's become pretty significant now. I have a picture that I couldn't find that has 3 cart loads about 4 foot by 2 foot carts of manuals for all the equipment that went into a small hospital that was transported and handed over from the construction company to the hospital management company. That's not going to last very long, okay? None of that's going to last very long. And how do you keep it up to date? You cannot keep it up to date. So, the system as we have it now is absolutely useless. So what do at the end of that? We just quit, and the building managers and operators and owners come in, and then they start building up their knowledge of information, and they know what parts of the building give trouble and what kinds of equipment give trouble. Don't buy those kinds of lighting fixtures, don't buy these kinds of other things because they're going to start giving you trouble. And then that kind of goes zigzag. It depends on personalities. I'm dealing with one of those right now. Received an email early this morning. I'm programming a new college of geosciences and received an email from the director of facilities there saying, I just wanted to remind you that the 28th of February will be my last working day because I'm retiring. So I don't know what plan you told my boss about, but can you please tell them that to remember to take all the information that's in my mind? And I'm thinking to myself, there you go, there's a building information repository walking out the door, and we're going to lose all of that. Now, BIM is not going to replace human beings, okay, but it starts to get a whole lot better. If we hand over three-dimensional, information-rich digital models from one phase to the next, and from one group to the next, and then from that group to the one after that, what would happen is we would reach a very high level of information in the model at the end of construction. Okay? We don't necessarily need all that data to operate the building, so it will drop a little bit. And that's fine. And then we will retain a fairly even level of knowledge about the building to be able to manage it. Okay? There are two levels. This one, there are two areas here, that one and this one, where there is very little work being done on the modalities, on the standards, on the processes, on the best practices. You're business folks, you know all that stuff, right? That's what you know better than most people. It's an area rich for work to be done. That's wrong. Okay. Just to sort of put make that point a little stronger, this again is based on numbers. Okay. As we start to make changes, the further on we are in the process, the more expensive it starts to become. When you're making changes, when you're preparing drawings and designs and stuff, it doesn't cost you very much. When you start making changes after you've started construction, it becomes very, very expensive. On the other hand, the decisions that you make that would increase value, the earlier on you make those decisions, the higher the increase in value of your project. And so, those decisions you don't have to make over here to have any value because it's already set in place. When you put this one together with that one, I think if you overlay them, which I really should have done, you'll see that it's a no-brainer that we have to have some methodology by which we transfer information all the way through. So maybe this is the best way. Here again, I don't know the figures for India. Trust me, I tried to find them, but I could not. I had two students looking almost full time to see if they could find any of this information. So I'll give you some American information. Okay, time is spent after it is constructed. 16% of the total life cycle cost of a building goes in design and construction. Okay, where would a smart person put his or her money? Where you, the 84% side of the market, it becomes important. McGraw-Hill does these smart reports, and they came out with this, and what was very useful was that quote which says, BIM, which began primarily as a design tool and then evolved into a must-have for leading contractors, and I explained to you the value of it for contractors, is now rapidly gaining traction with owners around the world because of what I just showed you. They have that much more information and it's more accurate, it costs them less money. How many of you know of, you're all business folks, you know this, an REIT, Real Estate Investment Trust, okay? The fastest growing investment opportunity in the world. Which country in the world is the hottest investment opportunity for REITs? India. Okay? REITs have now started investing big time in BIM. And what I'm talking about is not even more than 6 months old, okay? But they have started investing big time in BIM because there are real savings to be had because they're interested in that 84%. Okay? So I think, have I made the business case? Okay. So, what we'll do then is, no, I don't need to do that. I can do this. Really no software on the market to enable that to happen. Of course, now we are starting to see some of that software, and much of that comes straight out of this. I mean, just Autodesk is kind enough to give us money to support students so that two things happen. One is we do discrete projects for them, and two is they hire our students. So projects that revolve primarily around the university because it's really easy for us to get information when we do this. Okay, so here's the model. This is what I'm talking about. Okay, any integrated model, that means something has to have data that deals with the topography. It has to have data that deals with the buildings. It has to have data that deals with the vegetation, the natural environment around it, and it has to be able to integrate that data effectively so that they're all in the correct place, and the trees aren't out there and the buildings out somewhere else and the streets going up in the air and things like that. It gets a little difficult when you're doing that three-dimensionally. But that's what we're talking about over here. And that means there's a lot of data, okay? So after careful consideration, one option I had was to throw up my hands and hit the liquor store, okay? And there would have been lots of people to go ahead with me. And the other option I had was to see if we could start to do that by going from GIS to BIM automatically. And there's a whole list of students whose names I should have made darker, and the last four of us at the bottom over there are faculty. But we took the university and we took regular GIS data that we got from LiDAR data sets, okay, and we started to write software that put that into put that into a digital terrain model, and then started to overlay that again, and started to overlay the street data, and then started to overlay the building data. Now mind you, the building data was in AutoCAD drawings, the building data was in ArcGIS, the street data was in ArcGIS files, and the topography data was LiDAR data, which is aerial scanning data. Okay, talked a little bit earlier about data transfer. This is a great example of that. So just for the heck of it, we then took that drawing, building information model done in Revit, and we made a physical model of it. Now that got everybody's attention because this is a nice big huge physical model. It's about 6 feet across that way and it's about 8 feet across that way and about 11 feet this way. So, anytime there's a change in building, we throw out the building and put in a new building over there on that model. But this is an idea of what that campus plan looked like when we had it in there, when we transferred the data digitally. It was a very painstaking process to make sure that the algorithm was correct. And you can see that there's a whole lot more data than we need. Okay? Nobody needs all the data of all those little contours over there. No one needs all of that data if you're talking about a particular building. Okay? But you can manipulate that, and then you can just remove the other data when you want it. You remove the contour data entirely, and you only have blocks of buildings, okay, that show you buildings in relation to each other. Okay, you can't see all these things, but this gives you an idea. Those two things give you an idea of how you would choose what you want to look at and what you would turn on and turn off. Okay, and then of course, if you wanted to query the model, here's a dialog box. You go in there and say you wanted to see architecture and geosciences. That's just because they're next door to architecture. So it comes back and it says, okay, all the blue, that, and that, and that, and that, and that, all of that is architecture, and all the green is geosciences. Okay. Simple query box, query it, get that. A little difficult to do with any other technology. Okay. It would also come back and tell you how many square feet there is in each of those that it just did. Okay. And you can look at it differently, of course, obviously, if you didn't want to see it in that. And then you can pick out, let's say, just that bit, and you want to look at something in that bit in more detail. I'm actually going right after that because that's the building that I have the most data for. Okay, so that's the building. So you remember this building? Okay, that's the real thing. That's the real thing. That's the digital information model. And we get plans and elevations and sections and movie walkthroughs and quantities and details and all kinds of things off of it. Okay? And that's a real model. These are screenshots that show you what that model looks like. So this building here is the one we're talking about. That one is the other architecture building, and that one there is where we have that wood shop and everything else that I told you a little earlier. Okay? And obviously we can look at it from different places. We can look at it with the sun differently. We can have different information that we get different drawings out of, standard architectural type drawings, okay, plans, elevations, sections. But this is the more important thing. They're not just drawings, there's information in them about use. So we can almost instantaneously know who is where, in which office, what's happening, how we use it, and all of that, and it's almost instantaneous to get all that information. As a matter of fact, you get everything, including, the types of doors there are and the light fixtures that there are in there, a whole lot more than you would ever want. But you got a problem. We've got so much data that we've got. What are we going to do with it? Use it, just gather all of it and use it later. Well, have you ever noticed that the people who actually use BIM software are not the same people who need that information? They're completely different people. So we go back to the same old problem, right? I need the information and I've got to talk to you and convince you that, be sure that you understand what I need and how I need it, because I don't have a clue what the building information model has, only you have that. We're back to the same old problem. It's a little bit better, but we're back to the same old problem. So we figured that if we could put that on the web, and you could go point to it and get a bunch of dialog boxes coming up and down, that would be really nice. So, that's a building, we took that door over there, just clicked on the door, you get to know exactly what that door is. You want to change that door, you can go change that door. Okay, you can do the same thing with, this is another project, similar, this was actually historical building that they were doing renovations on, and so we were able to try the same thing out with that. But then we were able to connect it to pictures of the real building and where the information, and all that information is on the net. So you don't need to be an expert at manipulating BIM, you need to be able to use the net, and everyone knows, everybody knows how to use the net. Okay? It's the internet of everything. So we tried that out for the campus also. Now, of course, I'm trying to get the campus to pay for this. I don't want to subsidize them by providing them free software. So we showed them a proof of concept, and it's an interactive campus map which will be three-dimensional, and then people anywhere in the world, we could do it from here, click on it, and it would tell us everything that that there is about that building, that comes straight from a building information model that lives with us. Okay? So, there's one very, very important aspect of building information modeling that I have not touched on at all. Okay? And that is the ability to simulate. What do doctors do with their mistakes? They bury them or cremate them. Okay? What do architects do? They try to grow plants in front of them, trees, all kinds of things. As Frank Lloyd Wright said, architects cover them up with ivy. Okay? There's another weird thing that's been happening recently. The architects that make more mistakes don't seem to get repeat work. Now, why would a client go back to somebody who makes a mistake? This is the built environment to be able to simulate the performance of the built environment in advance of us actually building it. Which one of you would go and buy a car that had never been tested? Nobody. Which one of you bought a house that had already been tested? Nobody. Are we crazy or are we crazy? Which costs more, the house or the car? The house. So let me get this straight. The less expensive thing we want tested, the more expensive thing we really don't care. Not a very good business decision, right? Okay, so this becomes very, very important with building information modeling because it now gives us the ability to test this. I have to tell you a little story over here. Okay, so the first time I ever saw something being tested digitally was at the Mercedes-Benz lab in Stuttgart. in 1987. Okay, we were designing the Chrysler Technology Center in Bloomfield, Michigan, and Chrysler said, no, the Mercedes digital test facility is the best in the world, you'll have to go see that. Oh yeah, who wouldn't want a chance to go see the Mercedes test facility? So we all fought with each other, and I was one of the lucky guys who got to go. And I literally saw a suspension being tested on a screen. And it kept going through these reps at random and taking readings to see at what levels the metal starts to fatigue and things like that. Okay. We don't do this stuff for buildings. And we get a good number of buildings that fall down just because we don't do that. So, case study. Took a building that really exists, this thing really exists in Massachusetts, and made a building information model of it, and then started to see if we could optimize thermal energy and daylight performance using only the window dimensions as variables, and that's, when I say construction properties, that actually should be the thermal properties of the materials. Okay? Using Dynamo and Grasshopper and some of those parametric modeling tools, what we're able to do is we're able to make connections, and then the machine starts testing these things and optimizing it, looking for the best example. Okay? What it is able to do for us is, if you look at these here, each one, it's changing some things. See, it changes the windows on each one, and it's computing the energy use, and it comes back and tells us, you know, these just throw them out, forget them. These things are close, look at these if you want. Okay. Okay, so this is what we were actually, this is what we were messing with. Oh, and we did have the real building too. We had the data of the real building. And then of course we could look to see you know, what the thermal implications were based on the use, what the lighting implications are. And you get a whole bunch of models that actually start to show you visually. If you showed me all that data in sheets of paper, I wouldn't understand a thing. Okay, if you showed it to me this way, I start to understand that, you know, where there's red, there's a problem, where there's blue, there's less of a problem. Okay. As I start to wrap this up, there are a couple of things that I want to make. Leanne Doody, does anyone know the company Arup? Yes. Yeah, heard of Arup. Arup has a very interesting little unit that operates Arup worldwide. Okay, and that unit essentially has 38 people in it, and they look at the future. Okay, and this came from the lead of the Smart City Group. In that, and there are various other groups that they had. But this is what Leanne had to say. BIM is transforming not only the way buildings are designed and constructed, but also how they are managed and developed in the light of changing customer needs. Okay? Very, very important. I'll let you read the rest, but I'll draw your attention to that last sentence, which says, data delivered through BIM at a building level will be an important enabler of these new value chains. And I say that because it's up to you to determine those new value chains. Guys like me are not going to. Okay, I'm not tomorrow's consumer. I'm yesterday's consumer. Me, I'm coasting now. I just want to retire. Anyone know where that is? The Dome of St. Peter's in the Vatican. Absolutely. Anyone seen that? The model of the Dome of St. Peter's in the Vatican City. The first building information model I ever saw. It was constructed in 1547, took a few years, by my friend Michelangelo. And why did he do it? For all the reasons we just talked about. See, this guy had to be really smart. He would have drawn that graph before Eastman did. Okay? When Michelangelo was given the commission to do the dome, he was in his late 60s. He knew very well he could not complete design and construction of it. Nothing like that had ever been done. So they had to test, they had to simulate. Okay? So he had a whole series of very interesting problems ahead of him. One, he had to develop the technology. You develop technology by building prototypes, right? Two, he had to test the technology. You test the technology by subjecting the prototypes to actual performance conditions. Okay? Three, you have to transfer that information to somebody else to construct. Because plain and simple, you were just not going to be alive. Okay, you were dead. Michelangelo died in 1567? 1564, something like that. Yeah, I think 47 was when he got the commission to do the dome, and I think in 1564 he died. And this thing, this thing went through all manner of little modifications and changes and things after Michelangelo died, but essentially remained the same as it is today. Okay? So building information modeling is not new. Its reasons for existence are not new. It's just that we have a whole lot better way of dealing with it now than we ever did before. Okay, so I close with something Voltaire said. It is said that the present is pregnant with the future, and the present is the offspring of the past. Thank you.